Okay, hello, good evening, everybody. So welcome to the channel. My name is Victor, and I'm going to be anchor for this training. So this is a training. This is as well a question and answer session. So here, there are a few things we want to do. We want to understand some of the likely questions that might come out or that you should understand, and this can help you prepare for any networking exam, fundamentals. It can be CCNA 1. This is also a very good way to prepare for networking aspects of security exams like Security Plus, like of course CCNA 1, Cisco Cyber Ops. Now, if you are getting to do cybersecurity, there are some fundamentals in networking that um, you should be aware of, right? So if you're new to the channel, don't forget to subscribe. I'm going to be working in the more series to come in this Q&A sessions. I'm going to be bringing out roughly about between 100 to 200 questions per sections, either in networking or in cybersecurity and data analytics and several other areas. So these questions are meant to test and gauge your knowledge about most of the concepts you are learning. So networking. So this is a follow-up series on the CCNA 1 training you have on the channel. So if you are new to networking, you can check the channel to see the content we have on networking, either the CCNA 1, that is Introduction to Networking, or Routing, Switching, and Wireless Essentials, or the Cisco Cyber Ops. Okay, so the very first question we have here is, what does OSI stand for in the context of networking? What does OSI stand for in the context of networking? So this is very simple. This is very basic, but it is something you should understand. Networking is built on the OSI model. That is the Open System Interconnect. And it's just a framework that helps us to tell how devices connect amongst themselves. So I would normally say open system interconnect or interconnection model. So it's 7 layers. So if you're a student of networking, you should understand the different layers. You should understand what happens at the different layers. You should understand the devices across the different layers. So typically, I would say, please do not take sweet potatoes alone. I love potatoes a lot. So the very first layer being physical, then data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Let me just click on images. So this layers tells how the different systems you have in your network should communicate, should network. So it's like you saying two systems, you have two systems, and how will two of the systems connect? So we normally say data encapsulation and data de-encapsulation. So once the data is moving from the top down, right, from any of the applications, you're going to have data be encapsulated. And once it gets to the next system, that data is being de-encapsulated. The data has been opened up till it gets to the application layer. So you have 7 layers, right? And you call that open system interconnection model. I guess what's wrong? Okay, let me write on. I'll come back to that shortly. So you have something like this. So you have physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. So for security analysts, you want to know what the vulnerabilities are in each of the different layers. And of course, you also want to understand the protocols, the port numbers for the protocols in each of the layers. They also want to understand the vulnerability within each of the layer. Okay, take for instance this image. This image is going to tell us okay, this is what is going to happen in each of the layer. These are the protocols in each of the layer, this physical layer. You also want to understand what are the components of each of the layers, right? Very, very critical, very, very important. If you're into networking or you also want to transit into cybersecurity. So the next question we want to look at is, what layer of the OSI model is responsible for converting data into readable format for the application layer? Don't forget you have these layers. So what is going to help this layer to be able to see what is being transmitted from bottom up, right? Of course, it's going to be the presentation layer. So what is going to help present this data to the application layer? So it's the presentation layer. So let's see what the answer is. So it's presentation layer. So presentation layer ensures the data that is presented in a readable format for the application layer, handling stuff like decryption, data compression, and the rest. That's why you're going to see that the protocols that are in the presentation layer have to do with presenting data. So is the data encrypted, right? Is it email? How do you have files that are transferred over FTP, or is it in picture format? Is it in video format? Is it in, how is the data being presented? So the right answer to that question is going to be presentation layer. Okay, the next question is, which protocol is commonly used for secure communication over a network? So as a security analyst, you should be able to understand the different types of protocols. You should understand the protocols that are plain text and the protocols that are what? Secure protocols. So you want to have a table. You want to list all the plain text protocol. You also want to list the encrypted protocol. So protocols like HTTP, hypertext transfer protocol, those are plain text protocol. They don't transfer data in secure format. But HTTPS, which is port 443, of course, transfer data in a secure protocol. Same thing, FTP, of course, 20 or 21, those protocols, they are plain text protocol. SFTP, those protocols are secured protocols. SSH, secured protocol. Telnet, unsecured protocol. So if you are configuring the network, you want to make sure that you are using what? Secured protocols. So the answer here is going to be what? SSH. So if you check all of the protocols, the protocol that can transmit data in secured format is what? SSH. The next question is, what does DHCP stand for in networking? So of course, here you have dynamic host configuration protocol. You have domain host configuration protocol. You have distributed host configuration protocol. And you have data host configuration protocol. So the correct answer here is dynamic host configuration protocol. So there are two ways you can configure a network to distribute IP address. So when we talk about configuration protocol, we are saying that if we have a network, how do we, together with ARP, address resolution protocol, how do we distribute IP address to each of the devices you have on your network? If you have a router, if you have 10 devices, let's say a laptop, a desktop, a mobile phone, how does the router assign IP address to each of those devices? There are two ways. We can do that in a static format, in the sense that we have to fix IP address in each of the systems manually, or we allow the router, we allow DHCP server to assign IP address dynamically, right? Once we allow that to happen, dynamic host configuration protocol is at work. So the correct answer here is what? DHCP, dynamic host configuration protocol. So DHCP is responsible for assigning IP addresses and other network configuration information to devices on the network. So you also have, just a moment. So you have the next question here. Which security mechanism protects a network by filtering incoming and outgoing traffic based on predefined security rules? So here we want to have something that looks like an access control. So in which of these security mechanisms acts like an access control, where we're going to say, okay, port this, port this, you can have access. Let's say port 21, port 22, port 443, you can have access. So and so port numbers, you cannot have access. So what acts in that format, right? So is it a firewall? Is it a proxy server? Is that intrusion detection system? Is it a VPN? You can pause the video. Guess what the answer is? And the answer is what? Is a firewall. So a firewall monitors and controls incoming and outgoing network traffic based on predefined security rules. So if you want to ensure that you have security within your network, you do what? You set up your firewall. So a VPN is not going to do that for you. So a VPN is just going to make sure that you have like a tunnel, like a connection between two networks within a tunnel, right? So still over the internet. An IDS, an intrusion detection system, is going to help protect your system, right? But it's just going to detect if you have, let's say, an anomaly. And of course, a proxy server is going to help you connect to another network via another gateway. So, but a firewall is going to help you filter. That's why it's called a firewall. It's like a fence. Okay, the next question is, which type of attack involves flooding a network with excessive traffic, right? Excessive traffic to make it unavailable for legitimate users, right? So you want to push a lot of traffic, more than what a device or an application is going to cope with. So is it phishing? Is it denial of service? Is it man-in-the-middle attack? Is it spoofing? So you can pause the video. What will be your answer? What's phishing? Phishing is a social engineering methodology. Denial of service, where you have IT infrastructure, either a website or a network or an online form or a printer or a device, not just available for access. So this compromises availability, right? In cybersecurity, we say confidentiality, integrity, availability. Confidentiality, we want to make sure that people that are not supposed to have access to something don't have access to that. In integrity, we want to say that we must ensure that data is not pilfered with, data is not tampered with, data is not changed, data is not altered. In availability, we are saying that we want to make sure that all of the things that we need to have, that needs to be available for somebody is always available. So denial of service compromises that aspect of information security. So man-in-the-middle attack. So would that be the answer? So you have a situation whereby there's communication between 2 points and there's an interception to like pilfer or to steal or to tamper with the communication between those two devices. Or is it spoofing? So the answer is what? Denial of service. So denial of service attack will typically overwhelm the network. A very simple way this can be achieved, you see a website that have a bandwidth of, let's say, 30 gigabytes, and you send in traffic far more than the website can cope, right? Either through a botnet, or you see some of these black hat traffic channels. So you just typically render the website or the application inaccessible. So the correct answer to that is what? Denial of service. Now, which device forwards data packets between two computer networks acting like a junction between network? Now, in networking, we say there are end devices, that is your printer, your tablets, your phones, your laptops, all of those devices, you call them end devices. You also have your intermediary devices. So the intermediary devices are the devices that are going to help the end devices to communicate. So they are always within your network. Then you also have the last thing, which is connecting media. How will the communication be done? Are you going to be using Bluetooth? Are you going to be using infrared? Are you going to be using fiber optics? Are you going to be using internet cable? Are you going to be using wireless? So those are the three aspects of your network: end devices, intermediary devices, and of course, connecting media. So which of these devices is going to forward packets between two computer networks? So here you want to know the differences between a hub, a switch, and a router. Most importantly, we can skip out the modem for now. Those three classical types of intermediary devices, we want to know how they differ. So a hub is typically a junction box, right? So it's just like we call it also an unintelligent intermediary device. Whereas a switch is a very intelligent intermediary device. So it could act like the traffic warden. So the traffic warden at the T junction is going to say, okay, please, this guy, you can come, you can pass through this way. You guys, you can come, you guys, you can hold on, you can pass through this